Let's take a look at a function here that has had some transformations applied to the parent of the reciprocal function and see how that affects some of the characteristics of the graph. So here I have y equals 2 over the quantity x minus 3 increased by 5. That's the function that I'm looking at. And let's start off by seeing how these numbers in certain places are affecting the asymptote lines. So I'm seeing an x minus 3 in the denominator. Minus 3 in the denominator would actually translate the graph of this function to the right 3 units. So normally that vertical asymptote right there that is at x equals 0 has now been translated to the right 3 units. If I move it to the right 3 units, it would become the line x equals 3. So the vertical asymptote, just like the graph, has translated 3 units to the right. For the horizontal asymptote, normally we have that horizontal line of y equals 0. This plus 5 at the end represents a vertical translation of 5 units, moving everything up 5 units. So that right there is also going to take that asymptote line from y equals 0, translated up 5 units to y equals 5. And that's how the asymptote lines are affected by these transformations. This 2 instead of the 1 on top does represent a vertical stretch by a factor of 2, but that does not have an effect on the asymptote lines here for this function. Now let's talk domain and range and how these are directly connected to the asymptote lines that we're seeing for this function. So when we're trying to talk about the domain, the x values, where the function is defined, well, this function is defined everywhere except where its vertical asymptote was located. We talked about how this minus 3 in the denominator translated the function as well as its asymptote right 3 units. So there was a vertical asymptote where x equals negative 3. I'm sorry, where x equals 3. I misspoke there. Where x equals positive 3 when I move to the right 3 units. So if there's a vertical asymptote where x equals 3, and that's the only place then where this function is not defined, we need to make sure our domain represents that. So we'd have to build our domain from left to right, starting at negative infinity up until the 3 where it's undefined. Parenthesis because we don't want to include the 3, and then union to resume the rest of the domain from 3 to infinity. So there's how our domain would look in interval notation for this function with a vertical asymptote of x equals 3. Likewise, the range. The ranges are y values, our output values. The parent function has all output values except any with y value of 0. This has been translated up 5 units, and it moved that horizontal asymptote from y equals 0 to y equals 5. So this function will have all output values except y values of 5. So we need to represent that. We need to build that from bottom to top, excluding 5 with that. So starting at the bottom, negative infinity, until the problem of 5. That's where we don't have that output value of 5. Parenthesis to make sure we exclude it. And then union to resume the rest of the range from 5 on. Again, making sure we have a parenthesis to exclude it to positive infinity. Again, make sure you're always building your interval notations from least to greatest. For the domain, the x values, it's from left to right on a number line. For the y's, again, it's still least to greatest, which is bottom to top of that vertical axis number line. Sometimes I see students have something mixed around and they have negative infinities over here on the right end, and that just doesn't make sense for this notation. Let's talk now about finding the x-intercept. Although the parent function didn't have any x or y-intercepts because of where its asymptotes were, now that I've translated this function to the right 3 units and 5 units up, it actually will be crossing the x and y axis, so let's figure out where that would happen. Starting with the x-intercepts, I'll go ahead and plug 0 in for y and solve for x. So I will have 0 equals 2 divided by x minus 3 plus 5. The first thing I'll do is I'll subtract 5 on both sides of the equation to get negative 5 equals 2 over x minus 3. At this point, I need to get the variable off the bottom, so I need to multiply both sides by x minus 3. That would cancel out on this side, and I need to have over here the negative 5 being multiplied by x minus 3. That would just leave me with 2 on this side. Again, multiply this side by x minus 3. It would cancel out the x minus 3 that's on the bottom. I need to do it to that side as well. Now I need to go ahead and distribute. So I have negative 5x plus 15 is equal to 2. I can go ahead and subtract 15, and I'll be left with negative 5x is equal to 2 minus 15 would be negative 13. And then finally dividing both sides by negative 5. would leave me with x equals a negative divided by a negative is a positive 13/5, like that. Again, I'm okay with you leaving it as a fraction. Since the fraction is fifths, you actually could put this as its equivalent decimal. 13/5 would be the equivalent of 2 3/5 or 2.6 for that. So either one of those would be acceptable for the x-intercept. It's 13/5 or 2.6. You could also write that as an ordered pair if you wanted, like 13/5, comma 0. I'll accept that as the coordinates of the point. That is where it crosses the x-axis, or 2.6, comma 0. That's fine. But I'm okay with you just saying the x-intercept is 13/5 or the x-intercept is 2.6. But that would be fine. But if you want to write it as the ordered pair, you certainly can, knowing that its y-coordinate would be 0. Now to find the y-intercept, we'll put 0 in for the x and solve for y. Actually, y will already be by itself, so we'll just have to simplify. So we'll have y equals 2 over 0 minus 3 plus 5. So we have y equals 2 over negative 3 plus 5. Put the negative out in front of that. So I have negative 2/3 plus 5. I'm going to go ahead and write 5 as a fraction of thirds. With that, 5 would be 15/3, like that. And then I can go ahead and combine those, actually add those fractions together now. Negative 2/3 and 15/3 would make 13/3. Again, since that's with thirds, I would have repeating decimals if I tried to write an equivalent decimal, so I would have to round if I was going to try to put in my decimal answer into this program, since it doesn't let you put the vertical or the little bar above the number, the horizontal bar for the repeating decimal. So we're going to have to leave our answer to that as 13/3, which if you wanted to write that as the coordinates of the point, I'd be okay with that too. Since that's on the y-axis, that would be 0, comma 13/3, like that. But you can certainly just tell me the y-intercept is 13/3, and I would be perfectly fine with that and accept that answer.